Okay, one of my favorite topics nowadays is I'm working from home is the VPN because this is helping us do telecommuting to the College of Charleston. So let's say I want to work from home. Specifically, there are some things that I cannot do from home, such as access the native banner and remove holds for my advisees. So now I have a VPN connection with the College of Charleston network, and my computer is a trusted computer, even though it comes from my home. It's like in a virtual network together with all the rest of the College of Charleston computers, and I am able to access grades or other sensitive information. There are different implementations for VPN. There's the secure sockets layer implementation and the IPSec layer implementation, but overall, it is truly an extra layer of encrypting and authenticating, something to add to a set of protocols that is not very secure. So I said that there is an implementation that is called IPSec. It's almost like an extra layer on IP, on the network layer, just to add encryption and authentication. So it's a very nice idea. You can even set up your own VPN at home. I have my own VPN at home where I implemented using Raspberry Pi, so my phone can connect to the home computer. However, again, it's almost like a patch on top of an unsecure internet. So an implementation of a VPN can be seen in the slide where you have side-to-side VPNs. Data is encrypted from one gateway to another. As you know, a gateway is the router that takes us, our local networks, to the public internet. And that can help organizations that are located in different countries to trust each other, to share documents without having any threats to their intellectual property and, of course, the safety of their data. It can also be used for mobile users, so that gateway-to-gateway type of VPN, virtual private network. This slide actually shows that layer of security that I was explaining, where we have the IP layer, and inside that there's encrypted email and all of the traffic that goes through your VPN has an extra added layer of cryptography and authentication. So we discussed about how we can secure the application layer with the secure sockets layer and HTTPS, but the VPN is trying to address the lower layers security, and specifically the IP layer, the network layer. So an SSL VPN is imitating how IPSec works, but with a lightweight client. And the first time a user accesses the VPN gateway via a browser, they log in and they access the VPN, and then all settings are done via browser, and that's very easy to set up. This is not how the College of Charleston VPN, for example, works, where I actually have to use a VPN client that implements VPN at the lower layer. So the IPSec is what we use at the College of Charleston. It's a layer 3. It's a low-level VPN. It's the lower we go in the layers of the networking stack, the closer we go to the operating system. But the good thing with that is that it can protect any higher layer, and it has flexibility, but it's difficult to set up. So my home VPN, where I can use my phone and connect to my home devices, or have my PC being a trusted device and connect to my home, that's a browser VPN. That's an SSL implementation of VPN. The enterprise VPN that we have at the College of Charleston is using this more complex implementation of IP secure VPN. So I'm not going to ask you for too many details of IPSec, but it's really worth looking at how it gets implemented in the IP protocol stack, where you have the top layer, the application layer, the transport layer, and then between the transport and the network layer, there is an extra layer that is added for authentication and encapsulation of the contents and encryption. And as you can see here in the transport mode, there is encryption of the payload and an ESP trailer. And you can see that there's an additional header added between the transport layer and the network layer. And this header ensures the integrity of the data with the hash function and the authentication and the sequence numbers are also preventing for the replay attacks. We have discussed about this sequence number type of attacks. And overall, it's a very well thought mechanism that adds some additional complexity and additional headers to an already quite loaded set of layering system, as you may have understood while you were learning about all these layers and the headers and their additional fields. A different mode instead of the transport mode is the tunnel mode, where even the routing information is encrypted, and there's an encrypted tunnel. And besides the data contents, also your IP addresses are also encrypted, and that is using a different IP header than the original IP header. So you see that this is the difference. And just FYI, in case you were wondering, network address translation is supported in tunnel mode, which of course is needed because most networks right now have NAT. So that's definitely something to support. Finally, a great application of VPNs is onion routing. You may have heard of the Tor network, where you have to use a specific browser, and data is encrypted from client to server. No intermediate host can know who even the recipient is. So this is like a tunneling type of mode. A header is added by each router. Each router, all they need to know is the next hop and not the final destination. And this completely ensures privacy, anonymity, and then through a VPN also there is confidentiality and privacy of the data.